So because this G is the same for the first here, now we are supposed to factor the G as the subject, and also at the right side here A is common. If it is common, we are supposed to introduce a bracket here and factor the common variable out. And after this one, my dear student, we should say that. But we know that torque must be equals, in order to get tension, torque must be equal to tension times distance. Kwa hiyo tuweze kumpata yule torque, tunachukua force times perpendicular distance. Lakini sasa let us imagine that we was having, instead of using the force, we was trying to use the tension for the wheel. Now we could say the torque must be equals to the tension, then we times it by the perpendicular distance, or torque must be equals to the moment of inertia, we times it by the angular acceleration here. So where this tension must be equals to T2 minus T1. Lakini tunajua sasa ili tuweze kumpata yule tension, tutachukua ni sawasawa na wale difference of the two tensions. Tutachukua yule tension 2 tutatoa na sawasawa na tutatoa na ile tension 1. Therefore we could say that tension must be equal to tension 2 minus the tension 1, and also torque must be equal to tension times the perpendicular distance, which is equal to angular to the moment of inertia, we times it by the angular accelerations. So after this one, my dear student, since we know that also the acceleration divided by r must be equals to the angular acceleration. If the ratio of the acceleration divided by the radius is equal to angular acceleration, now we could say that the torque must be equal to I times A divided by R square. Turudi tena hapa kama tulivyoona, kwa sababu tumeona torque ni sawa na I times alpha, huyu kama tunavyoona ambaye ana represent the angular acceleration. Kwa ukija sasa kumake huyu tension at the subject, huyu ukitumia hapa tension times r ni sawasawa na moment of inertia, we times it by the angular acceleration. If we use this relation here and make tension at the subject, we could obtain tension must be equal to the moment of inertia times the angular acceleration divided by the perpendicular distance. So after this one, my dear student, we should take this alpha and substitute into our relation that we try to prepare here. If we substitute, tutapata sasa kumbe huyu tension must be equals to alpha, then we times by the A divided by R square. This should be our force equations. So after getting tension equals to I, then we multiply it by A divided by R square, where A huyu represented the acceleration and the R represented the radius, while this I represented the moment of inertia, and finally T could represent the tension. Now we could say that this might be our equation number 4. Must be our equation number 4 as we try to see. Now let us let us substitute equation number 4 into number 3. Let us take our equation, this equation number 4, and substitute into our equation number 3 as we try to demonstrate here. If we substitute, my dear student, we should take that instead of writing the difference of those torque, as we tried to see that the torque, this tension must be the total tension that is applied for the wheel must be equals to tension 1 minus tension 2. Now let us factor out negative. We get tension 2 minus tension 1. Instead of writing that tension, we are supposed to write the formula of the tension that we obtained here. Na hapa tulijaribu kuona hawa T tension ni sawasawa na T2 minus T1. Kwa baada ya kuandika yule T2 minus T1 tunaweka tension, lakini tension huyu tumeshamdemonstrate ni sawasawa na I times A divided by R square. Ndio kitu ambacho kimekuja kikatokea hapa. tumeondoa wale difference of the tension, my dear students. So after this one, what we are supposed to do here, we have tried to substitute, and that's after substituting, let us make acceleration at the subject. Sasa tujaribu kumeki yule acceleration at the subject ili tuweze kulijibu swali letu kama tulivyoulizwa huko. How can we make this acceleration at the subject? The first step, my dear student, is to take this value and the common value to collect at the one side. We are supposed to take this I times A divided by R square and add at the right side. If we add at the right side, we should remain at the left side that M2 minus M1 bracket G is equal to M2 plus M1 bracket A, then we add by I times A divided by R square. Kwa hiyo tukimchukua tukampeleka kule tutatengeneza equation yetu, lakini lengo la kupeleka kule ni nini? Ni kuweza kumake acceleration as the subject. So if we put at the right side, let us continue factoring out the acceleration. Now if we factor out the acceleration, now M2 minus Mg bracket minus M2 M1 bracket G might be equals to M2 plus M1, then we add by A by I divided by R square mabano kwa A. Let us divide by this M2 plus M1 plus I divided by R square so as to make a subject. Ukifanya hivyo, jibu utakalo kuja kulipata hapa, utapata formula ya kutafuta acceleration ambayo ni sawasawa na M2 na bracket of M2 minus M1 times the acceleration due to gravity, then we divide by I divided by R square, we add by the summation of the mass that we have been given. So from this formula, this M1 represent the mass of the particle 1, and also M2 represent the mass of the particle 2, where I represent the moment of inertia of the liquid body, while R represented the distance for those masses. So after this one, after getting the formula, my dear student, now let us go and try to substitute the value that we have been given into our equation. As we have tried to demonstrate the given data, we said that we have the masses which is equal to 0. Mass 1 is equal to 0.2 and also mass 2 equal to 0.25. Now we could substitute. If we substitute and multiply by this acceleration due to gravity divided by this one, 0.125, which represents the moment of inertia, then we divide by R square, which is equal to 0.15 meter bracket square, and add this 0.20, then we add by 0.25. After this one, let us take our calculator, my lovely student, and try to solve this equation. Kwa hiyo utakachofanya hapa ni kuchukua calculator yako na kujaribu kusubstitute ili kuweza kutafuta jibu ambalo ni 0.085. There are two only method here you can use into your calculation so as to solve this equation. You can use the direct method or indirect method. Direct method utaweka mabano makubwa kwa zote hizi, alafu utazitoa na kuzidisha. Baada ya hapo sasa tutakachokifanya tutaweka alama ya kugawanya kwenye calculator, alafu tutaweka mabano makubwa tena, alafu tutaziandika, tutafuatilia haya mabano tulionao, mwisho wa siku tutabonyeza kwenye equal sign. Or you can use the indirect method by finding the difference, and after there multiplying, and after there write the numerator, the answer that you will obtain at the top, and also you could find this one and add with this one. Finally, you could get equal to 0.085 meter per second. So after this one, my dear student, we could from the third equation of motion. Now after obtaining the acceleration, which is equal to 0.085 meter per second, now we are supposed to recall the Newton third law equation of motion, which said that v square must be equal to u square, we add by 2as. Kwa tutakachokifanya hapa tutaweza recall Newton third law. If we recall, then we know that AC/DC is the distance. AC is the distance moved by each particles, and U is equal to 0. Kwa kama U ni sawa na 0 na yule distance sawa na radius, tutaweza kusubstitute kwa lengo la kutafuta yule velocity, ambapo velocity wetu atakuwa ni sawa na radical of 2as, but we know that this is 2 times a we have been obtained, which is equal to 0.085 and times by 0.15 then radicals. Now let us take our calculator and press these values, and after there we should obtain the velocity equals to 0.16 meter per second. So by saying that this will be the end of our session here, now I would like to invite you again for another session. I wish you all the best. Have a nice moment.